Hello, so this video is going to be the last video at the grade 5 level on solving inequalities, and these questions are a little bit trickier. And the reason is, first of all, because you've got double inequalities, but second of all, it is because you've got your missing variable, which is x, in not only the middle part of your inequality, but also on one part of the other inequality. Or it could be, like in the second example, you've got x parts in all three parts of the inequality, which means we've got to treat the inequality when we solve it differently. So the question this time is saying, it isn't saying solve, it is saying list the integer, which just means whole number values of x. But really, right, to begin this question, we've got to go and solve the inequality. And how do we do this? Because we've got x not only in the middle, we can't use our method of taking away 1 dividing through by 3, because we're still going to have x over here. So this time, we've got to almost consider solving this inequality first of all. Okay, and then we've got to go and let's use a different color, and let's go and solve, and then you go and solve this inequality. So very similar, but this time the middle parts with the right parts separately. So you'll get two separate inequalities, and then from that you can list your integer values. So let's begin with the red one. So here we're solving now. 2x must be less than 3x plus 1. And this is something that we can solve, okay? And it might look a little bit strange at first, but we'll begin with it. The issue here is I've got x on both sides of the inequality. Let's deal with that straight away. So I'm actually going to go and take away that 2x from this side and get it over to this side by taking away 2x also. And then what's going to happen here is that these guys, and let's use a very different color, otherwise it might get confusing. Let's use this sort of yellowy color. These guys here are going to cancel, which is good. So then they disappear. And 2x take away minus 2x, you're left with 0 being less than. 3x take away 2x is x, or 1x, and you've got that plus 1, which is still left over. I'm going to kind of just rewrite this a bit differently. This means x plus 1 is greater than 0, which is the same thing as writing x plus 1 is greater than 0. These here, they mean exactly the same thing, but just I prefer to have my x on the left-hand side. It's what we're used to, isn't it? But these two things here, these are the same thing, okay? And then from here, let's go and take away 1. Take away 1 from both sides, because we're trying to get x on its own here, and then these two here, they cancel. And you just got left over x being greater than 0 take away 1 is minus 1. So I've solved this inequality. The question is not saying solve it, it's saying list the integer values, but we'll get onto that bit in a second. Let's now just go and consider the second inequality, which is the bit in the blue, which we're saying 3x plus 1 must be less than 13. And again, we're solving it, you want to go and find the missing value of x. Let's go and now take away 1 from both sides. This is an inequality that hopefully we are pretty well versed in solving, and we're left with now over here just 3x being less than 13 take away 1, which is 12. That's divide both sides by 3, divide through by 3, because then what's left over, well, these 3's here, they cancel, and we're left with, on your left-hand side, just x, which is really good, being less than 12 divided by 3 is 4. Okay, so I've solved the inequalities, but it's saying list the integer values. So if I write out what this really means, you will see. So if x is greater than minus 1, we're looking at your numbers that are bigger than minus 1. And let's just write out a few. So bigger than minus 1, we don't include minus 1. We're going to start at 0. That's bigger than minus 1. And then we go 1, 2, 3, 4, 5, 6, so on and so forth. And that should be plenty for the time being. Over here, we're saying x is less than 4, but not including 4. So you would go from 3 to 1, 0, minus 1, minus 2, so on and so forth. So the question is saying, right, list the integer values for x that satisfies both the red inequality and the blue inequality. So basically, which numbers can you see in both lists? And we can see we have a 0 over here and a 0 over here. We've got a 1 and we've got a 1. We've got a 2. We've got a 2. And we've got a 3, and we've got a 3. Okay, so all of these values now bigger than 3, 4, 5, 6, so on and so forth, are not in common with anything over here. So the integer values that satisfy both inequalities are going to be 0, 1, 2, and 3. 0, 1, 2, 3. So your answer is just going to be 0, 1, 2, and then 3. And that is it, okay? That is all of your integer, just means whole number values that satisfy both inequalities. And you know what? Let's do a sanity check, and let's go and check our working, okay? And let's use a bit of a different color. Let's do that in pen. Okay, let's check our answer. That's always a good thing to do. Let's use one of these values, and hopefully if we put it into our original inequality, it should make sense. So if we go and use x to be equal to 0 and put it into the inequality, what is 3 times 0 plus 1? Is it bigger than 2 times 0? And is it less than 13? So 3 times 0 is 3. Sorry, 3 times 0 is 0, add 1 is 1, which is bigger than 2 times 0, which is 0. That makes sense. 1 is bigger than 0. And also, it is less than 13. It makes sense. Good. If you chose a value outside of this range, you would see the inequality breaks down. You can try it yourself if you want to. I'm not going to because the video will get too long. But that is how you solve a double inequality with x's in more than just the middle part of the inequality. So you can now try this one yourself. Give that one a go. It looks a lot more tricky. It isn't really. It's the same kind of thing as the previous one. I guess it is a bit trickier. So you can pause the video, give that a go if you want to, or you can watch me go through it, or watch me go through it at the parts you need some help. So hopefully you've given that a go, and I will go through this question now, and let's begin it. Again, because we have x's now not only in the middle, but also on our left-hand part and our right-hand part, we've got to go and kind of treat this as solving, first of all, these two inequalities over here, and then similarly, we would go and solve these two inequalities over here. So solving two separate parts of the inequality. So the part in red, we've got 2x plus 3 being less than 4x plus 5. And again, it says list the integer values. To do that, we've got to first go and solve both the inequalities. I've got x's on both parts of the inequality. Well, let's go and get this 2x onto this side, because I want to get the x's onto one part of the inequality. So let's go and take away 2x. Let's go and take away 2x, because then what happens there is that these two are going to cancel, which is good. And they go to 0, so I'm left with 3 being less than. 4x take away 2x is 2x. I've got that plus 5 left over. It's much easier to get the x part on the left-hand side. It's just easier. That's kind of what we're used to, isn't it? So let's go and do that. Let's rewrite this. This means 2x plus 5 is bigger than 3. So we can rewrite it as 2x plus 5 is greater than 3. And now this is something that we're really well versed in. We can take away 5 from both parts, because then these cancel and you're left with 2x being greater. 3 take 5 is equal to negative 2. So minus 2. So to get x, we can go and divide both sides by 2, divide by 2, which is good, because then these guys here are going to cancel, and we are left with x being greater than minus 2 divided by 2, which is minus 1. So I've solved my red inequality, okay, and my integer values that satisfy this inequality, again, are going to be not minus 1, because it's bigger than minus 1, so we start at 0, and then we go 1, 2, 3, 4, 5, 6, so on and so forth, and that should be enough to list. And now over to the blue inequality, where we've got 4x plus 5. 4x plus 5 must be less than or equal to 3x plus 7. And again, the issue here is I've got x's on both parts of my inequality, so let's get rid of that by taking away the 3x over here and taking away the 3x over here. I could have taken away 4x, but then I get a negative x, and it just makes things a bit trickier to deal with. So let's just go and keep it like this. They cancel, which is useful. 4x take away 3x is equal to x, and I've got that plus 5 being less than equal to, they cancel, just 7. Let's go and take away that 5 and take away that 5. And then these two here, they cancel. And we're left with just x, which is good. We're trying to get it on its own, being less than or equal to 7 take away 5, which is equal to 2. So that's my second inequality, and my integer values that work for this inequality are going to be less than or equal to 2. You do include the number 2 this time, and then we go to 1, 0, -1, -2, -3, so on and so forth. So we're just seeing now in both of our lists, which numbers can you see appearing in both? Well, I can see a 0 and a 0. I can see a 1 and a 1. And I can see a 2 and a 2. And everything else, 3, 4, 5, 6, is not common with these two. So my integer values for x here are going to be 0, 1, and 2. And that is my answer for this question. Let's highlight it in yellow. There we go. Okay. If you got that, then that really is fantastic, because I would say that is quite a tricky question, particularly at the grade 5 level, but it could come up. Okay, that's kind of the hardest you will see on inequalities, along with the quadratic stuff at the grade 5 level. Okay, if you got that, fantastic. If you didn't, you can always rewind and go through what you need to, but hopefully that was useful. Thank you.